This video will present solutions to the VCE 2023 Mathematical Methods Written Examination 2, Section A, Questions 16 to 20. Question 16 gives us information about f of x and about the product f of x times g of x. From this information, we can deduce that g of x is equal to e to the power of x take 1 all squared, divided by e to the power of x take 1. As this is not one of the answers given, we are going to need to simplify our expression further. This can be done by hand, first using index laws, and then factoring out x take 1 from the exponent. This process can also be done on a ClassPad. In the main app, enter g of x. Pressing execute, the ClassPad does some simplification. Tapping the simplify icon on the toolbar makes it do a little more. Unfortunately, all of our answers have factored exponents, and ours is not factored, so we will need to factor. Carefully selecting the exponent and dropping it into a new line, we can now swipe it and use the factor command found under Interactive Transformation. With this done, we can see that the answer is B. Question 17 asks us to find the expression for the volume of the cylinder made from this net. This diagram neatly relates the variables x and y, the dimensions of the rectangular sheet, with variables r and h, the radius and height of the resulting cylinder. The formula for the volume of a cylinder, pi r squared h, is a good starting point, but we are going to need to get that expression in terms of x and y to answer this question. Looking at the width of the diagram, we can deduce that x equals h plus 4 lots of r, and that y equals 2 pi r based on the circumference of the circular end of the cylinder. We can now transpose these relationships so they are in the form h equals and r equals. With this done, we can substitute the expressions for h and r into the volume formula, so now our volume formula is in terms of only x and y as required. Unfortunately, this expression is not in the same form as any of the 5 possible answers, so we'll need to expand that bracket and do a little simplification. This process can be done by hand. First we expand, then we simplify that second term a little, and then, as we have ourselves a common denominator, we can write the expression as a single fraction. This simplification process can be aided by our ClassPad. If I enter my unsimplified expression for the volume in terms of x and y into ClassPad's main app, a little simplification is automatically performed. Tapping Simplify from the toolbar goes further and sorts out that denominator for me. From here, grab that numerator and expand it, with the Expand command accessed via the Interactive Transformation menu. Question 18 concerns the number of local maxima of a trigonometric function. What makes this question a bit different is that both the function and its domain are expressed in terms of the parameter a, where a is a positive integer. A sketch of this, for the cases where a equals 1 and k equals 2, is one way to gain insight into this question. This is the case where a equals 1, a graph of sine x from negative pi to pi, a graph which has one local minimum. Moving to the case where a equals 2, this causes the function to dilate parallel to the x-axis by a factor of a half, which doubles the number of local minima from 1 to 2. Moving from a equals 1 to a equals 2 also doubles the domain, changing it from neg pi to pi to from neg 2 pi to 2 pi. This also doubles the number of local minima from 2 to 4. Based on this thinking, it seems that in the a case, there will be a local minimums per 2 pi of the domain because of the dilation, and as the domain is a lots of 2 pi, there will be a times a or a squared local minima altogether. This thinking convinces me that the answer is E. This can also be expressed symbolically. As period equals 2 pi over a and domain equals 2a pi, as there is one local minimum per period, there is 2a pi over 2 pi over a local minima across the domain. This can be simplified to 2a pi times a over 2 pi, which simplifies to a squared. Question 19 asks about the values of k such that this quadratic equation has a positive and a negative solution. A good place to start is to solve this equation using ClassPad's main app. Two solutions are given to us, as one might expect. I'm going to inspect them closely, arrowing right to see the second solution in full. On a handheld, this can also be achieved by tapping the Rotate button on the permanent toolbar. Due to the negative out the front of the brackets and the positive sign inside the brackets, this second solution will be the smaller of the two. So, if one is going to be negative and one is going to be positive, this one will be the negative one. Finding the k values for which this solution is negative can be done by setting the expression less than 0 and solving for k. Now turning to the larger solution and asking when it is positive, we get a second inequality for k. Looking at these two inequalities, k greater than negative 3/4 and k between negative 3/4 and 3/4, the common ground is between negative 3/4 and 3/4, so the answer is D. Question 20 presents us with two functions f and g and asks about the larger set of values for which the two composite functions, known as fog and goff, both exist. As the function fog is the natural log of sine x plus 1 on root 2, then sine x plus 1 on root 2 must be greater than 0. This inequality can be solved on my ClassPad. As the function goff is the sine of a natural log function, the only limitation is that the argument of the natural log function needs to be greater than 0, which means that x must be greater than negative 1 on root 2. Now we know the values of x for which fog and goff exist independently, we need to find the greatest interval for which they both exist. The lower bound of the intersection of these two intervals will either be negative pi on 4 or negative 1 on root 2, whichever is larger. I'm going to use my ClassPad to approximate these values to find out which it is. Based on these approximations, the larger value is negative 1 on root 2, and so that is our lower bound. The upper bound of x less than 5 pi on 4 can be seen from the first inequality. This is enough to know that the answer is A. If you are wondering about the periodic nature of that first inequality and why it does not generate more solutions for x, the reason is that x values from 7 pi on 4 to 13 pi on 4, which would satisfy both of our inequalities, lie above 5, and we are told that x is less than 5.